Alright, so this is another video about the example that involve substitution, the integration by using substitution. Alright, then for this question, again, it is quite long. So for those who are interested to try on your own first, you can pause the video first and then you can try. But maybe before you start, I just want to show you some flow for this example. Okay, so for this question, it doesn't look like very complicated. This is what they want you to integrate, and the final answer is log 8 over 5. Okay, but if let's say you go through with the question itself, you will see that there are a lot of different stages that you involve in this example. So first of all, of course, you need to do the substitution first. Substitution. After you do the substitution, okay, you will get something like this. Alright, so this is the first stage of answer that you should get if you want to try on your own. First stage. Alright, then the second stage is you need to go through with the partial fraction. That means you need to split the rational functions into partial fractions before you can do the integration. Okay, then if you want to, after you go through this, after you get a partial fraction, the second stage, you should get this as part of your answer. You will see this in your answer, in your solution. Alright, then after that, only you start the integration. The third stage is integration. And of course, the final answer, after you do the integration and you substitute the limit into the answer, right, you should get log 8 over 5 as your final answer. So I will strongly recommend you to pause the video here and then you go through with all the process here first before you look into the detail for all the steps that I discussed with you here. Alright, okay. So now let us start. Again, first by using the substitution, they want you to show this. Okay, as what I told you before, start from the substitution given in the question. So u is equals to e power x. Alright, so first step is you need to do the differentiation first. When you want to differentiate du over dx, you will have the original equation dx. Then if you replace it, you will have du equals to ex dx. Alright, and because this is the definite integral, alright, so for this definite integral, original question is in terms of x, therefore these are all the x values. Right, so you can do it like this. When x equals to log 4, what is the value for u? So u is equals to e log 4, and you should get a 4 here. So if you don't know how to get it, you just press calculator, alright? And then when x equals to 0, what's the value for u here? So u is e power 0, and you will get a 1. Okay, so once I settle all the parts here, then I will start to do the substitution. Alright, so I'm having log 4 and then power log 4 and 0 for the limit. Okay, so if I want to continue here, right, if I look at this equation now, I will split the e2x become ex multiply with ex. So ex multiply with ex, you'll get e2x, then divided by ex squared. e2x, you can rephrase it, become ex power 2 outside, plus 3ex plus 2, then dx. Okay, so now, first of all, I will want you to have to look for this one, ex dx. So the ex dx, you can replace it by using du later. Okay, then the rest of the example here, the expression here, you can replace everything by using the u. So I will start the substitution now. Log 4, you get a 4. Okay, so e power 0, you get a 1. ex is the u. Then divided by ex power 2, you're having u squared plus 3u plus 2. Then the part highlighted in yellow color, the whole thing is equals to du. Right, so I hope that you can relate what I write here. Okay, then after that, after you do the substitution already, so this expression looks like very complicated, but you will realize that you can actually factorize the denominator, become u plus 2 and also u plus 1 du. Okay, so you can see that we already get to this part, our part here. Alright, so that means you've settled for the first part. Okay, so if you want to have a look, all the expression here is in terms of u already, there's nothing in terms of x anymore. So you can start the integration. But if you look at the style of the question here, it is a rational function and you cannot integrate straight away like this. So it will be better if you can split it into partial fractions. So that's why I said all these questions are you actually need to have some experience. If you know what are the methods that you can use, right, then it's easier for you. Alright, so from here, based on experience, you should know that, okay, I should split it into partial fraction. Alright, so how can I split it into partial fraction? Okay, so maybe I will put it in this part. Alright, so to solve it in partial fraction, I will write it here. So u over u plus 2 and also u plus 1, I can split it become a over u plus 2, then b over u plus 1. Okay, so if you multiply the whole equation by the denominator that you have, you are having u equals to a, u plus 1, b, u plus 2. Okay, right. Then again, continue from here. I will let u equals to negative 1 first. If I let u equals to negative 1, then you're having negative 1 equals to b. So very obvious your b is negative 1. And then you also can let u equals to negative 2. So when you let u equals to negative 2, then you have negative 2 equals to negative a. And therefore your a is equal to 2. So from here, you realize that your rational function can be split off, become the partial fraction like this. Okay, all right. So once I split it, become the partial fraction already, then I can continue with my integration here. All right. So I know that this is equal to 2 over u plus 2 minus 1 over u plus 1. So we arrive at the answer that I want you to show in part number 2, stage number 2 here. Okay, and then after that, you realize that, all right, so now you can actually integrate all this very easy. Okay, so what kind of integration you should apply here? There's a straightforward formula. So because your u is power 1 and also outside the bracket is also power 1, you can integrate it and get ln something. All right, so 2 is a constant, you just copy. Then you have ln u plus 2 minus ln u plus 1. And of course, you have to substitute the limit 4 and also 1. Alright, okay, then you can start substitute the value in. So substitute the 4 into the equation. You have 2 ln 6. 4 plus 2 is a 6, right? Then minus ln 5. U plus 1, 4 plus 1 is a 5. Minus, then you substitute 1 into the equation now. You're having 2 ln 3, okay, minus ln 2. Alright, then now you need to start to rephrase everything so that you can get the equation, the final answer that they want, which is ln 8 over 5. So in my suggestion, if you want to combine everything, become a single ln, it will be better if you rephrase everything, put back all the number in front, become the power, then you group everything together. Alright, so I'm having ln 6 power 2. So when you bring it back, become power 2, right? So 6 power 2 is 36. Minus ln 5. Minus ln 3 square is a 9. Plus ln 2. Okay? So now, if you look at this one, you need to apply the property for ln. So if I want to combine everything, become 1 ln, very easy. In front of the ln, if it is a plus, that means multiply. If it is minus, then it is divided. Okay, so again, you need to have some basic idea of all these for the ln properties. Okay, so plus 36 plus ln 36, that means 36 with on top, minus 5. So minus 5 should be at the bottom because divided by 5, minus 9, so should be at the bottom of the fraction, which is multiplied with 9, and then plus ln 2. So plus ln 2 means multiply with 2. Okay, so from here you can slowly simplify it. So 9 can be simplified with this one, become 4. So 4 times 2, you get an 8, and therefore you're having 8 over 5. And this is how we get the answer. Alright, so again, this question will be, it is slightly longer. You can see it is slightly longer and it involves a few different stages. Alright, which you can see that you actually combine all the concepts that you learned before in this one particular example. Okay, so there's no shortcut for you to learn upwards. You need to really practice a lot so that from the experience you roughly know what is the correct method, what is the correct flow for you to settle one question. Okay, so this is the last example for us to have for the integration by using substitution. Okay, so for the next video, we are going to learn another integration technique, which is integration by part. Alright, so maybe before proceed to the next technique, please make sure that you try more example from this technique to make sure that you already know clearly how to solve all the questions on this part. Alright, so I'll stop here for this video.